All right, section 11.1 notes. On the right side of the screen, you'll actually see the work for question 1, plus extra stuff that I wanted to teach kids. But I'm going to start out with just a smaller group of data values, okay? Take a look at this. So when you have 6 different numbers, 1, 5, 13, 19, 30, and 42, and you want to find the middle. Now, I know, good old middle school, you can go cross off, as long as you have them in increasing order, you can cross off from each end until you get to the middle. I know, that's kind of how we did it before. What we want to do is we want to take half of the total data values, which in this case is 6, and this is going to help us find the middle. Now, it's either going to point you to an exact location of the actual median, or it's going to point you to 2 values that have to be averaged together. So, if you get a whole number, like we are right now, 3, then what that's telling you to do is take the third and the fourth number and average them together. Now, you know that in order to average them together, you would add the 2 numbers and divide by 2, which is what I show right here. 13 plus 19, which is 32, divided by 2 is 16. So that's how you find the middle of 6 different numbers. What if you have 5 different numbers? Like this group right here. Well, half of 5, well, that doesn't give me a nice whole number. What it does give me is 2.5. So what you need to do is round that up, and that tells you the exact location of the middle, which in this case is the 3rd spot in the list. Well, the 3rd spot in the list is 13. So if you take half the data values, that will help you find where the middle is. It's either going to exactly, it's going to be a point something 0.5, and you're going to round up, like the last example here, or it's going to be like the first example where you get a whole number, and that's when you have to average the 2 in the middle, the one you kind of were guided to, and the one above that. Okay, now, in question 1, the first thing they do is they ask me for the mean. Well, I always ask kids, well, how many numbers are here? And they always say, oh, 1, 2, 3, 4, 5, 6, 7 numbers. Well, the matter of factness is there are 59 numbers. And everybody's like, 59 numbers? Where'd you get that? Well, it's because we have 6 values, which are all 11. And we have 10 values, which are all 12s. Right? In other words, the frequencies matter. They add up to 59 different numbers. I just didn't want to write out 59 different numbers. Okay? So, how do we find an average? We add up all the numbers. Well, do I really want to write 11 plus 11 plus 11 plus 11 plus 11 plus 11? No. So I wrote 11 times 6, 12 times 10, 13 times 10. So I'm really just taking the value and multiplying by the frequency, and then, of course, we're adding them all up. And when we add them all up, we get 808. Then, of course, we divide by the total number of values, which is 59, thereby giving us an average of 13.7. Now, for the median. Where's the middle of all 59 numbers, especially if you don't want to write them out? Remember I wanted to do my little 1/2 of 59 trick? Well, half of 59 is, you guessed it, 29.5. And that's the one that rounds up. So we're looking for the 30th spot in the list. The 30th spot in the list. Well, we got 11 6s. That does not contain the 30th spot. Next, we've got 10 more numbers that are all 12s. So now we're up to 16 different numbers. That is not the 30th spot. Then we have 10 more numbers. Those are all 13s. So now we're up to the 26th spot. We still have not gotten to the 30th. And so in the next group, which is 14s, We have 17 of those values. That definitely contains the 30th number. So the 30th number in the group is a 14. Therefore, the median is a 14. You just kind of work your way up from the bottom. Last thing they would ask me for is the mode. The mode in this case would be 14 because it occurs the most, right? The most. And it occurs 17 times. Okay, move on to the next question. So, as I told you guys, or I will tell you in class, on the test, I'll have all the numbers in order for you, so you don't have to kind of figure out what the, where you don't have to line them up and accidentally miscopy or miss a value and not have it in your list. So we're starting at 9, going up to 375. So I wrote them out in order. Outliers. Outlier means a data value that seems way different than the others. That could be a low value or a high value. In this case, the 375 is it's not the worst outlier I've ever seen in my life, but it does appear to be different than the rest. There's quite a big jump between 237 and 375 compared to the other values. However, it could, like I said, it could be low or it could be high in a data set. This one just happens to be on the high side. Okay, so if you find the average, okay, we know how to find averages, right? We add up all the numbers and divide by the number of values that you have. Well, if you do that with all 14 values, right, you'll be dividing by 14. You get 161.8. But if you get rid of this one, then you only have 13 numbers. When you add them up, you divide it by 13, and you get 145.4. So the last value raised the average 16 points. That's a pretty significant bump for one number. Well, what about the median with and without? Oops. Let's do that. Well, the median with all 14 numbers, if you take 14 over 2, or half of 14 if you want to say it that way, that gives me a whole number, 7. So I know it's the 7th and the 8th ones that we're going to average together. And that gave us 157. If we get rid of the 375, so half of 13, that's a 6.5, which we know that points me to the 7th. And the 7th one in the list is 142, so that's my median. There is no mode on these two because nothing repeats. Nothing repeats at all. You can have multiple modes. We do not have a mode on this one at all. Okay. Now, on question 3, oops. It's called a weighted average, all right? It tells you right in the problem to find a weighted mean, multiply each score by its weight, and add the results. So we went to the, lab reports, 40%. Okay, so we multiplied 80 by 0.4. And quizzes are 10%, so you multiply by 0.1, and the other two are each 0.25. So we multiply by 0.25, 25%. And then we add those up. Add them up, and we get 81.65. That's called a weighted average. Okay. There's two different ways to do this next question, and the only reason there's a second way to do it is because the percentiles were 25 and 75. If they were anything different, like 20 and 60, then I couldn't do the second method. It's only because it was 25 and 75. So literally, here's what we should be doing. Take the number of data values and multiply by 0.25. Take the number of data values, multiply by 0.75. This tells me the place in the list. The 5th place in the list is what I'm looking for. The 15th place in the list is what I'm looking for. So I literally just have to go, as long as the values are in order from increasing from least to greatest, then all I have to do is go find that value in the list. So the 5th one in the list is 6. And the 15th one is 13. I went on to ask more questions here, so I'll teach that to you right now. So I've got my 20 numbers written out, my 20 different data values. I taught everybody how to find a 5-number summary. Now, the 5-number summary includes the minimum, which is not hard to find, and it also includes the maximum, which is also not hard to find. Those are 2 of the 5 numbers. Then we need to find the median. Well, it's not too bad, right? We know how to do that. Take half of 20, or half of the number of data values, and get 10. So we know it'll be the average of the 10th and the 11th data values, right? 10th plus 11th all over 2, which happens to be the 8 and the 10 right in the middle. If you average them together, you get 9, right? 8 plus 10 all over 2 is 9. Okay. But that splits my data set up into 2 groups of 50%. And I know not everything's perfect, but, but 2 groups of 50%. If I split each of these pieces into 2, then I would split everything up based on 25%. So literally, I go find the median of the lower half. And I also find the median of the upper half. Well, those are 10 numbers each. And there's 2 values stuck in the middle, the 5th and the 6th. So that means we average the 5th data values and the 6th data values of each one of those sets, which is 6 and 7 for the lower one and 13 and 16 for the upper one. And that's how we end up with the 6.5 and the 14.5. Okay, so this is my 5-number summary. Min and max are easy to find. Median, not too bad. And then I just find the median of the lower half and the median of the upper half. Quartiles are defined to be, they're like percentiles, except that they're very specific. What is going on? Why can't I erase? That is weird. let me erase. Okay, I don't know. Oh, because that's not on that background. It's, oh my goodness, I'm so dumb sometimes. Okay, so quartiles are based on 25% chunks. So quartile 1 has all the data from the minimum to 25% of the data. Median has everything from 0 to 50%. Quartile 3 has everything from 0 to 75%. Technically, the max has everything from 0 to 100%, but I'm sure you probably know that. Okay? Percentiles, as we have noted, are at or below a particular level. Okay, what percent of all data values are at or below 37 in this data set? Percentile means at or below. So in this number 5 here, we have the number 37. Oh, why is it doing that? Let's get this going. Let's get this going. Okay, 37 is right there. That's 37 out of 20, which is 0.65, which corresponds to 65%. The 20 is the number of data values. Okay. That being said, it looks like I did the 5-number summary just for kicks and giggles, just for extra practice. This is a weird group of numbers that starts, it's got 6 3s at the beginning and 6 88s at the end. If you imagine this as a data set of test scores, this would be a really weird thing to see on a test. I mean, 70% of the kids from 57 on down failed the test. Only 6 kids passed it, and they didn't do a bad job at all at passing. Okay, so that's kind of a weird group. Let's see. Later on, I'm going to show you how to find the variance, and variance is a measure of how spread out the data is. This is going to have a high variance, and consequently what we call a high standard deviation. In other words, how spread out the data is. We kind of have a measurement for that. Okay. No, that ain't it. Okay, so it's not hard to figure out the average, right? You add them all up, you get 90. You divide by the number of values, which is 10, and you get 9. They have this kind of cool notation over here, which is, come on, get that off. That cool notation is X bar, and that's how they actually read it, X bar. Now, I also wrote these out in increasing order because I was just messing around and asking kids to practice with the 5-number summary. And that's, we took half of 10 numbers. That was 5, so we knew it was the average of the 5th and the 6th, which is the 9 and the 10 in the middle. And then we went to the lower half and found the average of the lower half, or I should say not average, median of the lower half, which is 4, and the median of the upper half, which is 12. Okay, so that's how we found our 5-number summary. We were just practicing. What we really need to mention or talk about is something called standard deviation. Now, what is standard deviation? Standard deviation is a measurement of how spread out data is. When the data is grouped closely together, we have what's called a low standard deviation. That's because data is close to the mean. All right, so the mean would be in the middle, and the data is close to it. But when the mean is here and the data is spread way out, we have what's called a high standard deviation. So question 5 up above, it has a high standard deviation. I think that, and we use the Greek letter sigma, which is this lowercase letter right here, to represent standard deviation. I believe when I did a calculation with one class, it was 37.9. Now, work your way all the way down to question number 7. Question number 7 had a standard deviation of 2. Drastically different, drastically lower, and I think you'll be able to see once we do the calculation. It's not hard. We're going to use Desmos.com to do it, but this is the idea. Low standard deviation means the numbers are close together. High standard deviation means they're farther apart. All right, let's look at a data set here. Let me pause this for a second and get a data set entered. Okay, so I have the graphing calculator, Desmos.com. It's /calculator open. Do not use the scientific version because it doesn't do variances for us. Okay, so we've got the numbers. Let's go with 2, 4, 4, 6, 9, 10, 2 12s, a 15, and a 16. Okay, so there is the group for question number 6. 10 elements in that list. Notice that I put them in brackets. Okay, now I highlight, copy, and I did copy that, all right? I copied this whole thing because I'm going to come down here and I want to find the variance. Now, Desmos, the graphing calculator portion has a feature in it to find variance. Variance is an ugly formula that I'm not going to ask you to solve or find, okay? So I do need a set of parentheses, and I'm going to paste this in. That is how quick the Desmos takes in order to find you the variance. Now, how do I go from a variance to a standard deviation? Well, it looks like we get rid of the square, and the way we get rid of a square is with, you guessed it, a square root. Now, you could type SQRT. You can also go find the actual keyboard on Desmos, and I think you click on that button at the bottom of the screen, which is kind of off the viewing window. Okay, now I don't want to type this whole number in there, so I'm going to click on it, copy it, click underneath the radical, and paste it in there. 4.85 is my standard deviation for this. Okay, not bad. Okay, definitely you could tell that the values are closer than the data set in number 5 when they're really spread far apart. Okay, so let's try this with the last one, 10, 12. Now you notice that I'm not putting them in order. The only reason we really need them in order is if we're finding the 5-number summary, where we need to find the median, and we need to know which place is which, that kind of thing, and the quartile 1 and the quartile 3. But if we just need the variance and how spread out the data is, I don't need to have them in order. Whoops. Okay, so highlight that whole thing, copy it, come down here, variance, paste it. Okay, so the variance is 4. And just like I said earlier, SQRT, copy this, put it in here, paste it. We get a standard deviation of 2, and that's the end of that. That's all we had to do on that particular video.